Right, honors geometry. So the next two set of notes are extension notes for you guys. The first one is on what are called permutations and combinations. I think you've done what's called the fundamental counting principle in the past, which is where, say, I have 3 shirts, 2 pairs of pants, I don't know, 4 pairs of shoes. How many total outfits can I do? There's also the one with menu options, right? Appetizers, main courses, desserts, right? How many different total food combinations can I make? Well, same kind of thing here we're doing with permutations and combinations. One major difference between the two ideas. So first, a permutation. A permutation is a distinct arrangement of some group of individuals. So when we say distinct, what we mean is order matters. So when we're picking our group, it matters what comes first, what comes second, what comes third. Okay. Now, in order to do permutations, we have to know what a factorial is. This is a symbol for factorial, in factorial, the exclamation point. It's the product of numbers starting with the number that you have in front of the exclamation point, and it goes all the way down to 1. So n times n minus 1 times n minus 2, all the way down to 3 times 2 times 1, right? So if it were 5 factorial, it'd be 5 times 4 times 3 times 2 times 1, whatever that is. Okay? When you do a permutation, this is your notation, NPK. It represents the number of different permutations of k individuals from the entire group of n. Now, this is the formula for a permutation. Again, the formula is kind of archaic. When I was a kid, I had to use the formula, but we have a calculator that can do the symbolism for you, or I'm going to show you how you can use factorials to do these permutation questions as well. I think they're a little bit simpler with permutations, with factorials. But you can also use the formula if you want to. Now, combinations are a different story. So combinations, which in my opinion are a lot more usable, is where the order doesn't matter. Okay, order doesn't matter. You're just trying to pick k individuals from a group of n. Again, we're going to use Desmos graphing calculator to do this. In the Desmos graphing calculator, it's going to be NCR instead of k. Again, here's the formula. The only difference is they add this, k factorial in the bottom. Again, we're going to use the graphing calculator for our combination problems. Okay, so again, when you're doing these problems, you have to ask yourself, does order matter or does order not matter? And we'll try to do some examples to kind of give you an idea of how to choose the correct answer to that question. Okay, so let's look at a problem here. Okay, so it says a blood bank needs 15 people to help with a blood drive. 20 people have volunteered. Find how many different groups of 15 can be formed from the 20 volunteers. So we're just giving blood. It doesn't matter who gives it first or who gives it last. So this is a problem where order doesn't matter. Order does not matter. And if order doesn't matter, then we're doing a combinations, right? So NCR. We want to pick, or NCK, whatever. We want to choose 15 people out of 20. So this is 20, choose 15. So let me show you how we're going to do this in Desmos graphing calculator. So when you do this problem, you're going to type in NCR and open a parenthesis, right? The first number is the n, the bigger number, comma, the second number is the smaller. And there you go. There are 15,504 ways to pick 15 people out of 20, and the order doesn't matter. That's it. 15,504, right? There we go. Done. Okay, let's try to do another problem here. Okay, so here we go. There were 7 students running in a race. How many different arrangements of first, second, and third place are possible? Okay, so because we're talking about first, second, or third place, this means order matters. Order matters. And if order matters, that means we're doing a permutation. NPR, permutation. Now, here's how I'm going to teach you how to do this, though. I'm not going to use the formula. You can, but I think that's cheating. There are 3 positions, first, second, or third. So how many people could win first place? 7, right? There's 7 racers. But once somebody wins first place, now how many people can win second place? 6. And now once someone wins second place, how many people can win third place? 5. And to me, that's a lot simpler, right? 7 times 6 times 5. And we'll do that here. 7 times 6 times 5. And that's 210. Now, again, you could do NPR. There's 7 people. We're choosing 3 spots. It doesn't matter what you want to do. But I think that the this is my opinion, the factorial way or the fundamental counting principle way is the easier way to do it. And that's 210. There we go. So that's simple. That's one step permutations or combinations. Let's kind of step it up and let's do 2 steps. All right, so it says in a running competition, a bronze, silver, and gold medal must be given to the top 3 girls and top 3 boys. You have 15 boys, 7 girls. How many different ways could these 6 medals possibly be given out? So again, because you have bronze, silver, and gold, this is a permutations question, right? Order matters. So let's do the girls first and then the boys second. So girls. Bronze, silver, gold, right? This is for the girls. So we have 7 girls competing. So 7 for the first spot, and then 6 for the second spot, and then 5 for the third spot. Now let's do the boys. Notice I'm doing it right next to it. So for the boys, there's 15 competing for the first spot, then 14, then 13. And because we want this to happen at the same time, we're just going to simply multiply all that together. 7 times 6 times 5 times 15 times 14 times 13. That's it. So when you have to do a 2-step, it just means you have to multiply your 2 individual uh, permutations together. So let's do that right now. So it was 7 times 6 times 5 times 15 times 14 times 13. And there we go. 573 300. 573 300. 573 300. Okay, last problem here we'll do. Okay, so let's take a look at this one here. So it says a committee must be formed with 3 teachers and 3 students. There are 10 teachers to choose from, 15 students. How many different ways can the committee be made? So it doesn't say that there is like if there was a president and a vice president, that's where order would matter. But it doesn't say that. So this is a combinations question, combos. The order doesn't matter. You just need the committee to be formed. So we're going to use NCR. And let's do the teachers first. So 3 teachers out of 10. 10, choose 3, times NCR. And now let's do the students next. 3 students out of 15. 15, choose 3. And that's what we're going to type in with the multiplication symbol in between. 10, choose 3. 15, choose 3. NCR. 10, choose 3 times NCR. 15, choose 3. And there we go. If you use a lowercase c, I don't think it works, right? So make sure you use the uppercase c. 54, 600. All right. So good luck with this. Hopefully it goes pretty smooth for you.